Good morning. We'll find the Fourier transform of the given function x of t is equal to e raised to power minus at into ut, and what to plot its magnitude and phase spectrum. Therefore, the solution for this is whatever the function is given, it is like this of the nature. This is x of t. This is the time. On this side, it is infinity, 0 to infinity, and your function is exponentially decreasing. So it is a e raised to power minus 80. Okay, so we have to find a Laplace transform of this. So the Laplace transform, that is a transform which is used to transform the function in time domain into the frequency domain. Therefore x of omega is equal to the minus infinity to infinity integration over this into x of t into e raised to power minus j omega t into dt. Okay, so we have the function x of t is e raised to power minus 80 into u of t into e raised to power minus j omega t into dt. Now, as our function is from 0 to infinity, so we have to change the limit here. From minus infinity to infinity, it will be the 0 to infinity, and this and u of t is one unity. Therefore, we can write here 0 to infinity into e raised to power minus sign will take outside, a plus j omega into t, u of t is 1, and into this d of t. Now find the integration of this. So e raised to power minus a plus j omega into t, so minus 1 over a plus j omega into e raised to power minus a plus j omega t, and we have to put this limit from 0 to infinity. So if you put e raised to power minus infinity, it is a 0, and minus e raised to power 0, it is a 1. So therefore, if you put this like this, a plus j omega into, after putting this, we'll get minus 1. So what we'll get here? We'll get here 1 over a plus j omega. Sir, so this is the x of omega. So the magnitude of x of omega is equal to 1 over square root of a square plus omega square, and angle is, that is the angle of x of j omega is equal to as this is in denominator side, so minus tan inverse of omega by a. Okay, so we have to find now the phase magnitude and phase plot. So for magnitude, this is the magnitude and this is the phase. So when you put omega for different values, we have to find the magnitude of x of omega. So when you put 0, the magnitude is 1 over a, and when you put here minus infinity, your magnitude is 0. When you put infinity, your magnitude will be 0. Similarly, if you find the angle for this, so this is the omega and this is the angle x of j omega. So when you put here 0, the angle is 0. When you put here minus infinity, the angle is pi by 2, and when you put here infinity, angle is minus pi by 2. Now we have to find this magnitude and phase plots. So magnitude plot we can plot like this. So this is the magnitude of x of omega, versus the frequency, and here it is 0, and here on this side it is minus infinity, on this side it is infinity. So when omega is equal to 0, what is the magnitude? Magnitude is 1 over a. So this is magnitude. And when omega is equal to minus infinity, your magnitude is 0. So this is going like this, and at minus infinity it will touch this line. And when omega is equal to infinity, we are also getting 0, so we will get the graph like this. So this is the magnitude plot. Now the frequency plot is there. Now that is a frequency versus the angle. So we have already calculated this. Now so this is the again frequency. On this side it is minus infinity, on this side it is infinity. This is 0. So when your frequency is 0, angle is 0. So we'll say this is a pi by 2, because this is the angle of x of j omega, and this is a minus pi by 2. So when frequency is 0, angle is 0. When frequency is minus infinity, angle is pi by 2. So at minus infinity, this is coming like this, and at 0 it is 0, and at plus infinity it is a minus pi by 2. So this is the phase plot. In this way we can find the Fourier transform for the given function, that is a e raised to power minus 80 into u of t. Thank you very much for watching the video.